This conference will now be recorded.
Kita mula ya. Assalamualaikum and very good morning to all.
Waalaikumsalam.
Thank you for joining us today. Today we have Encik Anwar Faiz Osman from Rod and Shorts to present to us on a topic 5G EMF, the prerequisite to deploy 5G. Before we start, I would like to remind, please turn off your camera and volume to avoid disruptions. Please use your full name for us to capture your attendance. And if you have any question, you may submit through chat box. Okay, without further ado, I would like to invite Encik Anwar Faiz to give his presentation. Please welcome.
Thank you very much, Farazina. Assalamualaikum and good morning to everyone. First of all, I would like to thank all of you for attending this technical talk. My name is Anwar from Rod and Shorts. The title of my presentation today will be the 5G EMF measurement, the prerequisite to deploy 5G. Right. So before I start, let's explain a bit about myself. I'm currently working in Rod and Shorts as an application engineer. So I have 16 years of experience in wireless communication and also mobile network testing. Part of the IEEE member, and also for last year I was part of this Malaysia 5G Task Force, chairman of the 5G ecosystem and timeline sub-working group under the spectrum working group of the task force. I'm also the vice chairman of the MTFSB, IMT, and Future Network Working Group. And under this working group, we have come up with a technical code document, which is currently under the consideration for approval in MSMC, and that the title of the technical code will be Prediction and Measurements of EMF Exposure from Base Station. So this document actually covers a wide range of the method and limits to measure EMF from the cellular base station, which include 5G. So let's start with the agenda today. The first, I would like to talk about EMF measurement introduction. This is basically a brief introduction on why we need to do the EMF measurement as well as the scope of the measurement. And we will follow that with the legacy EMF measurement, means that what have been done in the past for non-5G technology to get the EMF exposure limit from the environment. Next, we will compare the frequency selective versus a code selective EMF measurement for LTE in 5G. For basically here we start to talk about the differences in measuring the EMF in the past, which is basically using the EMF monitor or the spectrum analyzer, as compared to the new method or more suitable method in measuring specifically for 5G EMF. Right. And we follow that with some 5G EMF test solution and field measurement results. I do have some demo result that I have done recently at the some of the 5G trial site. I will talk a bit on the Malaysia technical code for EMF base station, what we have put into the document, and we will end that with the conclusion. So why we need to do EMF measurement? So every time we want to, every time a country wants to deploy a new technology, of course they will be concerned by the public. Right? When they see a base station, 5G base station, for example, being assembled in their neighborhood, and then they will start to complain. Right? Some will say that they have headache. They see the tower, they will say that, oh, I since the tower had been erected, I have a headache every night when I sleep, even though the 5G tower is not yet operational. So these are like human perception or human concern. But the regulator and the industry have to address this concern by the public, right? Regardless. So EMF here means electromagnetic field, and the unit is in volt per meter, and it is a measurement to check the human exposure to electromagnetic fields, especially in sensitive areas like school, kindergarten, flats, housing areas. So those are the places that we can say as sensitive areas, right, where we have a congregation of people. And then we have the reason why we need to do EMF measurement is that to give assurance to the public, right? We need to provide evidence that the exposure to the electromagnetic field is below a certain threshold, which is then this threshold is defined by standards, by law or regulator. And we want to dispel doubts or to avoid health and safety concern from the public, to avoid delays of 5G rollout. Because if we want to deploy 5G and the public is against it due to perception of health concern, then we may need to stop the deployment. So we need to have this measurement to provide proof and dispel any concern from the public. So this is the excerpt that I took from World Health Organization, WHO. But the main point that I want to show here is the conclusion from WHO, which reveals that the EMF exposure below the limits recommended by ICNIRP, international guideline, do not appear to have any known consequence of health. So meaning, right, WHO, which is an organization that the public refers to when it comes to health, claims that if we do an EMF measurement and from a base station and the limit is below that as what given by ICNIRP, which I will explain later, right, then there is no proof that we have any consequences to health. Right. So the main important thing here that when we do the EMF measurement as a proof to the public that the base station is safe, the limit has to be below the ICNIRP guideline. Right. What have happened recently is that Switzerland, they wanted to roll out 5G, but the public is against it because they say that it's bad to the health. So the government has to stop the deployment for a while because they need to address the public concerns. So they need to do the EMF study quickly and to come up with the proof and the correct method to ensure the public that it is safe. So here, the reason why the public has concern for the 5G exposure is that even though the ICNIRP limit is the same, the frequency is the same as defined by the standard, but the method in measurement that the regulator in Sweden previously do is not accepted by the public. Right? So the public demand a better justification. So the regulator has to quickly come up with the method that can justify to address the issue to the public, to give them confidence that 5G is safe to be deployed. Right? So that's the importance of the 5G EMF measurement, which is to address the public concern on the safety and health. I think recently, even with coronavirus coming in, right? The public is some portion of public blame the 5G towers as a source of the virus. So you can see that this is definitely not true. But the point here is that when we want to deploy new technology, then a portion of the public or the majority of the public will think that it is hazardous, right? So it will come up with all this theory that some of these disease or viruses linked to 5G. So we have to address this, right? We have to ensure the public that this is not true. So we have to have justification. We have to have the technical proof to show that 5G is not hazardous to the public. Right. So now let's talk about the EMF standardization. What is the limit, or what is the scope of EMF measurement, which is related to human? Right. So the standard for EMF is based on the influence of electromagnetic field on human. So when you have a 5G base station, right, transmitting electromagnetic field signal, then there is a concern that the electromagnetic field can cause an increase in thermal at the human tissue. Right? So the standard here that is defined by some organization depends on the frequency of the technology operation, right? For example, in 5G, and also depends on the field strength or power density of the signal, the exposition time, what is the time limit that we use to measure the EMF, the modulation, right? The modulation here is very important because when we come to higher modulation signal like 5G, then the method to measure the maximum exposure will be different, right? We cannot measure the same EMF method in GSM, for example, as compared to 5G. It will be different because of the modulation and also the coding and the differences in the technology. And also we need to see, it also depends on the co-located and ambient radio sources. Means that in that area, apart from 5G or apart from 4G, what are the other sources that coming in to that area? So we have to identify the component of the measurement that we have done. For example, the EMF measurement, which portion come from 5G, which portion come from 4G, and so on. Right? And we have to look at the international recommendation, for example, ICNIRP, and also other organizations like IEC. Right? And then we also have regional limits and measurement procedures that is different between countries. So we can do the EMF measurement either indoor or outdoor, right? Just to get the EMF on a different environment. We can do a short measurement, for example, just a static test or current test, or we can also do a long-term measurement, say 24 hours measurement, just to make sure that we capture the maximum exposure in the area. And the reason why we do the EMF measurement can vary. For example, we want to compare the EMF exposure from different transmitters, right? Let's say broadcast or the cellular transmitters. We can also do the measurement for statistical reason, right? We want to get data for public information. But most of the time, we do the measurement because we want to make sure that the limit that the exposure coming from a base station, for example, conform to the regulation standard. Right? So, in terms like I mentioned before, the WHO is following ECNIRP, right? ECNIRP limit. So the limit is the same, right? The frequency is the same. However, there are various methods to measure EMF, and with 5G, it will be more complex to its flexible nature. Right? We have done a lot of tweaking to the radio system in 5G that the method to measure EMF is different from other technology. Right. So this is ICNIRP, right, which is International Communication on Non-Ionizing Radiation Protection. So ICNIRP provide a guideline to give a limit exposure of the electromagnetic field in terms of the human body. Right, so a lot of country and also international organization is following the ICNIRP standard. It covers the frequency from 100 kilohertz up to 300 gigahertz. So in ICNIRP, right, they have two standard for human exposure. One is for occupational means that for people who work in close to base station, and also a standard for general public exposure. So basically, right, we have electrical field component of the EMF, and also magnetic field component, which always available in any electromagnetic signal, right? And also there is a power density, which is independent of both field here, right? That we have to consider as well, right? So if you look at this graph here from occupational and general public exposure, right? After a certain limit, which is exactly where the after certain frequencies, which is where the mobile communication frequency is, the ICNIRP only specify the power density. This is because based on ICNIRP guidelines that after 2 gigahertz, the effect of EMF towards human body will be thermal, means that the tissue will be heat up by the radiation. So we have to make sure that the power density that the human is received is below this limit to be considered safe, right? And of course, the ICNIRP also specify that to get this measurement, we have to do a time average exposure of more than 6 minutes for the range of frequency that we want to do the measurement, right? And it has to be on the RMS value. Like I mentioned before, there will be two limits. One is for the occupational exposure and also the public exposure. So you can see at the power density, right? For people who work in near the base station, especially work telco engineers, they have a higher limit given to them as 50 watt per meter square. But for the general public, it is lower at 10 watt per meter square. Right, so it depends on whether the person is working near to the base station. So there's the limit is even higher because they're expected to be close to the base station during their work time. I also would like to emphasize here that ICNIRP also defines setting for the spectrum measurement of EMF depending on the technology, right? So you can see that for FM, for TV signal, for GSM, 3G, 4G, and 5G, there will be a different setting that you need. This is where it differs, right? In the EMF measurement. As mentioned before, the limit is the same, the frequency range is given, and it's the same, but the method is different if you want to measure for different technology of signal, right? And you can see here for 3G, 4G, the method is using the decoding of the reference signal, right? And for service with time-dependent traffic, which is what 5G is, then extrapolation is needed to get the maximum exposure when the network load is at the maximum traffic, right? So this is very important because the method of measurement will be different for different technology that we want to measure for the EMF. Right? Now this is just to show that some countries have more have a stricter limit than ICNIRP. For example, ICNIRP, this is the graph for ICNIRP, so anything below this is safe, but Germany has a lower limit, right, to make sure that they really address the public, and the most stringent limit is by Switzerland. Right? So when they have deployed the 5G base station, they have to make sure that the exposure is well below the ICNIRP level. Right? So this is just to show that even though ICNIRP give a guideline, but the regulators from each country can define the limit, but normally it is lower than what ICNIRP specifies. So what have been done in Switzerland, right, after the protest by the public, so that they come up with a technical report on the measurement method for 5G base station up to 6 GHz. Then they important here is that they are using code selective method that allows the compliance assessment of an installation with the installation limit value, which is considered as a reference method. Basically, what they are doing is that they are using the fundamental of the 5G technology to measure for the exposure coming from the 5G base station. So they are no longer using the standard broadband probe or EMF meter, for example, or the spectrum analyzer. So they are using basically 5G scanners as what the telco used to measure the coverage and to get for each component from the 5G base station. And then they believe that this is, based on their justification, this is the best and optimal method to measure the EMF from a 5G base station. And they come up with this report and submitted to the public. And it's and as after they publish it in 20th April 2020, the public has accepted after the presentation, and the 5G can now be deployed in Switzerland. So before we go to specific 5G measurement, EMF measurement, let's look at what have been done in the past, right? So just a quick one, right? Let's look at in the past, right? We are doing a broadband measurement of frequency selective, where we measure the EMF on the overall, the EMF power on overall signal, for example, the RSSI. Whereas for 5G, right, we need to do a code selective, where we measure power on a known signal, for example, the reference signal. This is called the RSRP, right? Using a setup here, right? And we measure the power at a known antenna, means that we need to know the antenna factor, because the antenna will no longer be isotropic as being done in the past. So they have different beam factors that coming from antenna. So one of the changes that we need to take note is that we need to know the antenna factor of the probe that we are using to measure the EMF. So in the past, right, what we have done is we can do an EMF snapshot, where we, for example, I have here an antenna, right? We just hold the antenna and do a single measurement, right, to get the estimation of EMF situation. So this is just to get a fast and brief overview of relevant transmitters, and also to define where we want to do the measurement, right? So we can use this, in this case, a broadband meter or a spectrum analyzer. So what we getting here is the live result, right? It's not a maximum value, it's just a live current value, just to give a realistic view, right? This is a fast analysis before we do a detailed investigation, right? So for this snapshot EMF measurement, we can do an automatic and accurate field evaluation by using the isotropic antenna, which covers all direction and polarization from 9 kHz to 6 GHz. Right? But remember, this is just a fast and brief overview. Right? It cannot be used as the report to show that the limit is safe. Basically, it's just do a quick measurement to identify the location where we want to do the detailed investigation. The other one is when we deploy a 5G base station or 5G tower, right? We need to do a transmitter site measurement. Right? And normally, right, over here we would need to know where is the isolation distance or the safe limit. Then we have to put the signage. In some countries, we have to put signage. So this measurement is dedicated to a single transmitter and is to measure the analysis of worst case, and it details setting of the signal parameter, either using a known downlink signal behavior, or we put in some assumption based on our the technical value. Right? So why we do this is because we want to measure when a new transmitter is put into operation or there is a modification being made. For example, we add more antennas to the tower, for example. Right? So we want to know where is a safe distance, right? How many meters from the base station is considered safe, and we want to put the signage. And this is normally done to address the public concern when a new antenna is being erected in a neighborhood, for example. So to do this test, we need a meticulous planning of measurement, and we need to know the theory, the strategy based on the objective, and also the country regulation. Now we start to see the different in terms of the technology. For example, in LTE, right, we have an antenna which may have asymptotic lobe, right, or the beam strength. The beam strength is small in other areas, but it is very strong on one area. So we need to know what is the radiation pattern from the antenna, right? Because we want to measure the worst case. Because that is what the public wants. The public wants to know what is the worst case EMF signal that is coming from the base station and where is the location. Right? So we need to know the antenna radiation of the base station and the field distribution of a directional antenna on elevated site. So normally have a few sectors. So we have to measure based on the sectorized antenna, right? With both vertical and horizontal directivity. So we need to put our probe here at the main lobe of the base station, right? So when you see the cellular base station with the antenna, we don't know, I mean for the public, we wouldn't know where is the main strength of the signal coming, right? Going at which direction. So this is something you can do by doing the measurement. Right? We can also do a multi-point method, right? This is a reference by some standard as shown here, 50400 or 50492. Basically, right, we have to put a tripod and we put the antenna at the tripod here, and the height of the antenna is fixed, right, between 1110 cm to 170 cm. So measure at 3 different heights. So the objective here is that we want to measure an average human body, right? So you can a person can be higher than 170 cm, but this is what we call the average person. I think 110 centimeter is basically for children, right? So it's basically represent the human body, and we are measuring the total exposure ratio at all measurement points. And we complete the frequency range measurement in one measurement, and we have to use the isotropic antenna for this case, right? And we have a 1 meter separation according to the standard to any reflecting object. Means that when you want to do this measurement, they should be in an open area. Okay. And then another method that we need to do is using what we call a stirring method. Stirring method means that when we do the measurement, it's not frequency, we have to move the antenna. This is called pivoting. Why do we do this? Because we want to get the maximum value of the EMF. Right? We don't know where it's maximum, so we have to do a stirring. Of course, there's a specific method in doing that. Right? So this is recommended by some countries in Europe, for example, Switzerland. So it has to use a handheld measurement instrument, and we scan the area by pivoting the antenna so that we can get the maximum value. Right? But for this case, we only do one service at a time. Means that if for the operator, right, they have multiple signals, so we cannot only do at one operator to measure at one operator signal at a time. So you have DG, Maxis, or Celcom. So we measure first for DG, and then Celcom and Maxis based on the frequency range of the application. And the last one is the long-term analysis. Right? This evaluation is to measure the emission over long hours, days or weeks or even months. So basically, we want to show the chronology of different services and to do the analysis of overall emission per service. We can do an automatic operation, means that we don't need to actually sit there. We can have the software and the PC running while doing the measurement. So the reason why we want to do this is because we want to prove validity of the short-term measurement. Because ICNIRP says that it has to be more than 6 minutes. So most of the measurement is done just for 6 minutes. But sometimes we took a sample. Right? We can't do this at all the site because it's not feasible to do long-term measurement for all sites. So basically, we just do a sample, one site, for example, just to prove that it will be the same as the short-term measurement. Right? So this ensures trust in the measurement data, and it can give the confidence to the public that the measurement of 6 minutes, for example, is sufficient to provide the EMF exposure from each base station. Next, we will talk about the difference between the frequency selective measurement versus the code selective EMF measurement for LTE and 5G. So in the past, right, for example, for LTE, when we do the EMF measurement, we are using spectrum analyzer, right? But using a spectrum analyzer, right, we can only get a pure power spectrum measurement. We have no identification of the carriers. We don't know whether it's 2G, 3G, 4G. When we put an antenna at the site, right, we don't know whether the signal that we are getting is from the base station that we want or from neighboring base station. Right? It doesn't show you the component of the EMF measurement. Right? So the public would like to know, I believe, is that what is the component of EMF exposure coming from a 5G base station. And in 5G, it will be much more complicated, where you have the antenna sector, right, in the base station can have multiple beam, right? And for each beam, there is a multiple radiation signal. Right? So we need to do a code measurement so that we can identify and decode the carriers and for each beam, so we can get the EMF value for each PCI, for each SSB, and for each antenna sector. Right? So it can determine the precise signal power level, and we can tell whether this is coming from the 5G base station. It will clearly show you that. Right? So in a measurement using a frequency selective or spectrum analyzer, what we are measuring here, right, is the all radiated signal that contribute to the EMF exposure. So it is based exclusively on power spectrum measurement. So we only get the power spectrum, right? And how they convert this to EMF is just based on that. So the received signal are neither decoded nor assigned to any technology, operator, or cell. So we couldn't tell whether this signal here coming from a specific base station that we want to measure. It can come from neighboring base station. It can come from other source of radiation that's available at that site. Right? So this method cannot identify which signal is contributing and what portion of the radiation. But if you use a code selective measurement, it can decode the signal and assign a level to a technology, a site, or sector, even to each beam, right? So this is important because we already have the legacy technology, 4G, 3G, 2G around. So when we want to deploy or erect a 5G base station, we want to know what is exposure coming from that base station. So the code selective measurement only measure a portion of signal, right? To, for example, from 5G beam signal, right? Then we can do extrapolation, and these extrapolation factors are actually being listed in, or the method is actually being published in standards like IEC 62232. Right? So we can use the extrapolation vector based on the measurement that we make from each beam for each of these sector in the antenna. So in charge of optimizing the emission to pass the under limit, it can be used to optimize the emission from a base station to ensure that it is passed under the limit. Means that when the operator do this measurement, right, then if it's close to the limit, then it can do optimization because it knows which beam that is slightly higher or a lot significantly higher than the other beam. So they can change the beam power that is contributing most to the EMF. So it's not just to get the measurement of the EMF, it also helps the operator in optimizing the radiation level from their base station so that it can have a better or optimum exposure from all the sector of the antenna, right? So by having this information about the contribution level from each beam, from each PCI, right, from each antenna, right, then it helps operator to optimize the team and identify the setup, so that when they deploy the 5G tower, right, it can ensure it to be below the EMF limit, as well as providing the maximum capacity and coverage, because they are using the scanner in this case, right? So they are actually killing two birds in one stone. They can ensure that they can get the measurement of the EMF limit. Then they can also do a coverage optimization. Right? So that's the beauty of doing a code selective method EMF measurement in 5G. Right? So just to show here that there are no real difference between 5G and LTE spectrum measurement, right, when EXTRAPOLATION method is used. So if you use the EXTRAPOLATION method, then there will be, so we can't differ between LTE and 5G. So we have to use the more specific method to get the maximum limit, and that is normally defined by IEC. Okay. So why is 5G is more critical regarding EMF exposure? 5G use this beamforming to overcome the pulse loss at higher frequency. So they have recorded here is SSB index, or the beam index, right? So we have one PCI can have multiple beam index, and we don't know the EMF value for each of these unless we measure it correctly. And as for the public concern, we have to get the maximum total EMF from each of the index, sum it up, and come up with a report. And in 5G, right, the antenna is become more intelligent, so it create a very narrow but high gain beam, so that we can have further coverage, right? We want to increase the signal to noise ratio. This is because by physics, right, if you go for high frequency, then the coverage is lower than the high frequency. But by using intelligent antenna, we can actually boost the coverage. But by having that, then the measurement to identify the EMF radiation is more complicated before. So this SLB beam can create a field strength hotspot in the very narrow main lobes of the beam. So just a quick one here. What I want to show here is that for this page, it's quite technical, but just to show that for you to measure the EMF, right, we need to measure on the SSP signal, which is always on signal in 5G. So for EMF exposure, we have to measure the RSRP of the secondary sync signal, or the SSS RSRP. So this is actually listed in the IEC document. Right. So 5G has become a bit more complicated as compared to the other technology. So the measurement to get the EMF will also differs and a bit more complicated as well. Right. Just to show that as defined by IEC, right, the extrapolation factor for 4G EMF is very straightforward. It's linear, right? So if in 5G, right, you have 12 resource element per resource block. So for example, I give you, if you have a 20 megahertz LTE signal, right, a bandwidth of 30 megahertz normally for LTE. So you have 100 resource block times 12 resource element. So you have 1,200 resource element for this total of 20 megahertz. So we can actually see that you want to get the total power per sector, we can just do a simple math here by dividing the total power from base station, which is normally at 40 watts, divided by this 1,200 carrier resource element. Then we have the power in milliwatts. This is the radiation level per resource element, right? And you can have a linear extrapolation factor, right, to get the element in dB, the emission level in dB. So it's about 30 dB. So it's quite straightforward. But in 5G, it is different. You can see here you only have one beam in one sector, but in 5G, one sector can have multiple beam, right? So it is not as straightforward as in LTE. So the exploration factor will be a bit more complicated, right? So what we need to do, when we want to measure the 5G EMF. Okay, the first we need to do the extrapolation of the SSB power to the full 5G carrier spectrum, right? For example, if I show here, right, we are only measuring a portion of the 5G, which is the always on signal. So we have to do this measurement for the SSB, right? And then we use the extrapolation factor to determine the maximum exposure that is coming from the whole bandwidth or the total carrier of the 5G signal. Then we also need to do a beam or gain offset between the SSB and the data beam, right? Because the UE specific data beam has a smaller bandwidth as compared to the SSB beam. So we need to know the offset, right? So this is by either measurement using the scanner, or we get the corresponding data from the network operator. The other important factor that we need to know is that the majority of signal in 5G services will be in TDD or the time duplex, right? So the frequency allocation for both uplink and downlink is the same, right? So if you look here, right, this is in time domain, right? You can have uplink, downlink, right? So if the uplink to downlink factor is about 0.5, means that you have half the time it is uplink and half the time it is downlink, then you need to put the relation factor as 0.5, means you have to divide by half based on the maximum the power that you measure. So you can see that it is getting more complicated as compared to direct and straightforward extrapolation in 4G as compared to the factors that you need to consider when it comes to 5G. So this is actually a step 1 only. So step 2 is that you need to sum up all the SSBs. So normally when we want to do a 5G EMF, right, we have a scanner here, right? So we want to find a location in a so-called sensitive area, right? And ICNIRP or some regulators define sensitive areas as housing areas, school, kindergarten, right? So we will need to do something like the stirring method or pivoting, right, in that area to find the maximum EMF exposure from a direct path, and also we have to measure for any reflection signal that's coming. So we have to that area, right, for the EMF exposure. So here you can see this is summation formula, right? So we have to sum up all the SSB signal beam, right, by doing the measurement, and we have to find the worst case scenario by doing the summation. So this is the maximum possible value of EMF that can come from this base station. Okay, and this is very important because we want to show to the public that we are doing the correct measurement method when calculating the maximum exposure of a 5G base station. Okay. Just a quick one on the 5G EMF test solution and field measurement result, right? So I have mentioned this before that for base station we have multiple SSBs, right? So we have to measure on the SSB, which is an always on signal. And let's look at the next page here. So basically this is a procedure where we use a scanner and a known antenna, which we can apply the antenna factor. So with this scanner, we can automatically detect all 5G carriers on air. We can decode the PCI, the SSB index, and also the master information block. And then we conduct the power measurement on the synchronization signal for each of these factors. Then it goes to a database where it starts to sum up all the SSB and calculate the electrical field strength per PCI for each SSB in the PCI, right? So we start to have a collection of data, right? Then we start to pivot the antenna like the steering method to search for maximum field strength per PCI, right? And applying the max hold function. Once we done the measurement at one side, then we can export it as and to do a post processing, right? And we apply the extrapolation factor to get the the highest maximum exposure limit that can come from the 5G base station, and whether the maximum limit is within the regulator limit or not. Okay. So we need to use a scanner because it's a passive and calibrated receiver with the highest achievable accuracy, right? Important thing here is that it can detect 5G and RPCI and SSB for each SSB, for each PCI, right? You can measure. This is very important because it's a method that we need to do when we measure the 5G base station EMF value. Remember, the volt per meter is a linear value. So if we're using the equipment that is not calibrated, right, then a differentiation in 1 dB, a deviation in 1 dB can cause a very high deviation in the final result. So we will not get accurate value. An important thing is that it can measure and decode the received power of SSB. So it can tell you the component for each of the EMF measurement that you made, whether it's coming from this base station A, base station B, from base station A, which sector, which SSB index. And normally what we do is that we have a phone or a tablet that's connected to the scanner. We are doing the measurement with the scanner because this is a receiver that we are using. This is a probe. The phone is only used to control and show the result. Right. So this is where you can see that we can detect the 5G signal, and also for each 5G signal, what is the reference frequency, what is the channel number, what is the PCI and index. So you need this information first before you do the measurement. You need to know what is a component. Then you start to do the 5G signal. Right? First, you measure the current measurement. Right? This is in volt per meter. Right? Then you start to pivot the data, steering. Right? Remember, I show you the steering method to pivot the data as the antenna, so that you can search for the maximum value. Right? Then once it's done, we can mark the cell. So from that cell, from that specific PCI, and SSB index, we can get the maximum exposure that is coming from the base station side. Right? So this is just for one PCI and one SSB. So you need to add for the different SSB for each PCI, and also for each PCI in the 5G transmitter. I would like to show some example that I made. We have done the EMF measurement in UTM-WCC, where I did the measurement, and I have shown it to the Ericsson and also UTM, the method of measurement during the 5G EMF. And we also done EMF measurement in DG 5G Open Lab in Requisite in Sabarjaya. You can see that we have the value here. Right? So it is under trial so you can see that most of the location where we have the trial base station, we have done the measurement using this method for verification. So the quick one, just to show you that what we have done in the NTFSP prediction and measurement of EMF exposure from base station. So we have done the public engagement, right, on 10th of June. Okay. So here we did we present to the public on the wide range of EMF scope of measurement, not just for 5G, but for all the cellular technologies. Right. So you can see here, this is the outline, and there is one agenda here is the 5G and R base station, which is basically what I have explained. It's a summary of what I have explained before. So we have put in together in the document the justification of the method that we want to propose and to explain it to the public. Right. So these are the members of the 5G EMF working group, headed by Professor Yamada from UTM. technical drafters. Right. So over here, we also put in the reference level for exposure to EMF, apart from the methods that we need to measure to get this. You can see that what we have put in reference is that anything above 2 gigahertz, for example, in the 5G 3.5 gigahertz range, for occupational workers is 50 watt per meter squared, and for the general public is 10 watt per meter squared. So this will be the limit that will be used by the nation when we want to measure and the EMF radiation from precision. So lastly, I would like to go for the conclusion. So with the commercial 5G network rolled out, right, EMF measurement a prerequisite to prove that the radiation is below the limit that's defined by the standard guidelines. So scanning receivers and special antennas are calibrated devices and therefore perfect for accurate 5G EMF measurement. We need to do extrapolation to help to measure and calculate the maximum EMF value when performing the 5G EMF measurement. And this extrapolation factor is also defined in the IEC standard. And with the code selective measurement, it's not just the EMF limit that we can measure, but the operator can use it to also optimize their network setup, right? So this will be the proposed 5G EMF measurement using scanners and a known antenna, a calibrated antenna. So for 5G EMF measurement using the traditional frequency spectrometer is not really recommended anymore because of what I have explained, due to the technology that's the complicated technology and the changes that we have made in 5G as compared to 4G or other legacy. So I've come to the end of my presentation. So I would like to pass back to Puan Razlina. By the way, thank you for joining, for listening to the presentation. Puan Razlina. Hello.
Okay. Sorry. I have 3 questions here.
Yes.
From the one of the participant. First
Okay.
question: what is the effect from the perspective of network deployment for countries like Switzerland and Germany when they lowered down the limit? Second question: 5G have the option to deploy either NSA or SA. Will the method to measure differs for these 2 options? How about for the case of dynamic spectrum sharing? And the third question, from end user perspective, exposure to EMF will be based on what they are being exposed, regardless from any service providers or any technology. Is it correct? If so, what would be the measurement method for this scenario? Okay, I hand over to you.
All right, thank you. I think the first question and the third question are relevant. It's related. Okay, so basically, right, the first question is what is the effect of Germany lowering their level as compared to ICNIRP? And the third question is that the concern from public is that the measurement is based on the total. Sorry, can you repeat the third question?
From the end user perspective, exposure to EMF will be based on what they are being exposed, regardless from any service providers or any technology. Is it correct? If so, what would be the measurement method for this scenario?
Right. Thank you. So for the first question and third question is basically on the public perception. Okay. Now 4G, 3G, or whatever technology that is being around, normally the public is no longer complain, right? Because it's whatever issue that they have, they already solve it during their deployment. It's 5G, is something new, something that is being talked about currently, right? So the it's the public, if you can see from even from the public engagement that we have, right? People want to know what is the specific exposure from 5G, right? And that's why when Germany and Sweden put the level to be lower than ICNIRP, is not to say that they want to be healthier or more stringent. It's because to give assurance to the public, right? So they have to address the public in terms of what the method they are using is justified. It's based on the standards, based on the right technical method, and also to show the public that look, WHO, ICNIRP has said this is the limit. We are making sure that the level is even lower than in. It's all about giving the assurance to the public, right? This is what those countries trying to do, right? They are trying to because they're in more developed countries, the public has a stronger voice, so they have to give assurance, and it's a matter of feasibility. Means that when they give that limit, right, means that in those countries they already made the study, they know what is the average limit of from a 5G base station, so it's a much lower. They know it's much lower than level. That's why they can make the standard to be more strict. And regarding the third question, right? So that is why okay. Regarding the third question is also related to the public concern, right? So when, let's say you're in a housing area, when the operator wants to deploy a 5G base station, and then they put a signage, these are 5G. Then the public become panic. Oh, this is 5G is going to be bad and hazardous to their health. So they will come up with a complaint or injunction to stop the operation, stop the building of the erection of the tower, right? So that is why we need to come up the method specifically for 5G base station just to address this issue. If you can also look at the MTFSP, right, you can see that all these other standard guideline exposure limit, all this prediction EMF measurement, right, is all for the other cellular band. But we for 5G is special. We have to do is based on the agreement and discussion for the group. We need to have a specific 5G method here, because this is where the public wants to know, right? Public, it's true that public needs to know the total emission, but they also have they will be more sensitive when a 5G base station is being deployed. This is what happening around the world, right? So that's the answer for question number 3, and also just now question number 1. Now to answer the question number 2, right, where we have the NSA, non-standalone, where we have 5G and 4G, and also in a more complicated situation is the dynamic spectrum sharing. Means that from originally LTE spectrum bandwidth, but we can add in a 5G signal. This is where the code selective measurement is more important, right? Because if you use a frequency selective measurement, you wouldn't know if especially in dynamic spectrum sharing, right? What signal coming from 5G or signal coming from 4G, right? So by using spectrum analyzer, it will get a total signal, right? And even in NSA, right? NSA is easier because you can, although it's based on the control panel is still by the 4G, but it's still on different frequency band, right? Let's say 5G is at band 78, but the 4G, the anchor band is at band 7, for example. So you can still measure at different frequency to identify. But for dynamic spectrum sharing, it is more important and more critical to use a code selective method using the scanner so that we can identify the component of 5G EMF and as well as a 4G EMF. In fact, we can do a code selective method using scanner to measure the EMF from the 4G as well. So that is a very good question, and what the presentation that I've shown here is to show that this is the right method to measure the best method, I would say, to measure the EMF for 5G, especially in DSS setting. Any more questions?
Okay. Any other questions? Any other questions, or anyone want to highlight anything?
Razlina, Nasruddin.
Yeah.
Just a follow up from the first question tadi. Boleh dengar, Anwar?
Boleh, Dr. Nas.
Alright. First question tadi, the question basically nak tanya, kalau ialah for countries macam Germany dan Switzerland tadi kan, I think you shared dia turunkan the level of ICNIRP. But itu soalan dia lebih kepada network deployment. Adakah kesan towards the service provider ke apakah, ataupun the regulators have to they have to adjust in terms of how they deploy or plan for the network. Will that affect those part of the network planning or deployment lah? I think the questions was along those lines.
Okay, thank you. Now I understand the question better. Actually, no, it has minimal impact towards the 5G deployment, because the regulator actually did a study on it's a balance between to ensure the public concern on the limit and to give a good limit to prevent a high exposure. But the other part is what is a feasible value, right? We cannot put a too low value until that we cannot deploy coverage. So in general, right, 5G is safe, I would say, right? It is safe because it's non-ionizing and the ICNIRP level is actually quite high as well. Right? You can look at, for example, we look at the power, 10 watt per meter squared is actually quite high. If you look at the measurement that I made, for example, for one PCI or for one SSP index, right? It is about 3.6 millivolt, or maybe this is in UTM. So if in UTM it's about 33 millivolt per PCI. So even if you add that up, right? Remember, if you convert that, let's say for the public exposure, 10 watt per meter squared is about 61 volt per meter, right? So you know that here is actually quite low. You know, right, where's a base station and where I'm sitting here is not that far, and we are measuring at about 33 millivolt. So if even you add that up, it will be around less than 5 volt per meter value. That I can say. So the regulator, they have made a study, so they know what is a feasible value. So they try to optimize it because the ICNIRP level is quite high. So they just to show to the public that, look, we are taking care of your need. We are lowering it for the operator to make sure that the operator did not go beyond the exposure limit. But at the same time, they already know what is the maximum that is coming from the maximum exposure that is coming from a base station based on the study of some deployment scenario. So it is not a value that they simply plug from the sky. It's actually feasible in terms of the deployment. So it's based on a study and based on measurement that they took care, they taken in the area. So we can actually do something like this also if we want to put the limit lower, actually, right? Because the ICNIRP level, to be honest, is quite high. But just the WHO and ICNIRP is trying to give the maximum value based on the human the tissue the human body tissue thermal effect, right? So It's actually from the 5G it's actually much lower than that. But anyway, the limit that is given by Germany and Switzerland is actually for sub-6. It's not yet up to above 6 gigahertz.
Okay, thank you for the clarification.
Thank you.
Any other questions? I think there's no questions anymore. Thank you, Encik Anwar Faiz, and thank you everyone for joining us today. I would like to remind after this session, we will send a survey to improve our session. Therefore, I really appreciate if you can spare a bit of your time to fill up the survey. Thank you and see you all again in next session. Bye.
Thank you
and
very much,
Assalamualaikum.
Thank you very much. Assalamualaikum. Bye.
Bye.
Assalamualaikum.